In the last chapter, you learned how we measure distance in one dimension using absolute value. And now we're going to move into measuring distance in two dimensions and look at some applications of that. Of course, there's more to this chapter than that, measuring distance, but it's a good start, and it's accomplished by the Pythagorean theorem. So you're probably familiar with the Pythagorean theorem, at least the classical form of it. The classical form of the Pythagorean theorem says if we have a right triangle, one with a 90-degree angle in it, perpendicular sides, and sides are labeled A, B, C as I have them labeled, where C is the hypotenuse, then A squared plus B squared equals C squared. That's the algebra relationship between the three sides. Well, the converse of that theorem is this. If you have a triangle which satisfies the algebra relationship, then you're guaranteed that it is a right triangle. So I think every college algebra student should see a proof of this form of the Pythagorean theorem. I have one in my book, which is probably the easiest one to follow that there is, but I'm going to present a different one for the video, for variety's sake. And in fact, it's a proof attributed to a United States president, James Garfield. So it has some historical curiosity value to it. This other part of the Pythagorean theorem, in order to prove this, I believe I've done this before. It seems like in order to prove it, you're deriving the law of cosines in trigonometry. So I stay away from it in college algebra since we're not doing trigonometry, but we do. You would see this in a trig class. All right. Well, by the way, let me, before I erase this, I have seen this applied. This second form of the Pythagorean theorem. Many years ago, in my youth, when I was promoted to be an assistant store manager for a large chain, and moved to Daytona Beach, and where they're building our new store. It was a very large store, probably about the size of the Kmart in town, almost that size perhaps. Well, the construction manager was still on site, and he explained how he laid out the building. And the building was in the form of a rectangle, and he said, well, this is what I did. He said, first I measured a length of string that was the front of your building. And then he put two stakes in the ground, and with that string pulled them tight, and that became the front of the building. And then he said he cut off a string that matched the length of one side of the building, this side of the building, we'll say. And then using this relationship, and I'm not even sure he remembered the name for it, but it's obviously the Pythagorean theorem was what he was using here. By using this algebra relationship, he calculated the length of the diagonal. Cut off a string in that length. When he brought the strings tightly together to form a triangle, then since this was satisfied, this became a right triangle. And therefore he had a nice perpendicular sides, on a very large building. You would never lay out a large rectangular building by using a little carpenter's square to form your 90-degree angles. That would create too much error. And so in order to get a very precise 90-degree angle, one that's very close to true on this scale, then this is what he applied. Well, that's probably construction 101 basics. I don't know. But I thought that was interesting when I saw that. All right, well, Pythagorean theorem is attributed to Pythagoras, and Pythagoras was a ancient Greek philosopher. In fact, he was the person who came up with the term philosopher. He lived in between 500 and 600 BC, and so he goes way back. He ended up settling in southern Italy, a town called Croton, and he formed a school, a philosophical school there, and ended up with a lot of followers at one point. In fact, the Pythagorean school lingered for over 200 years, even though it suffered some political oppression and or persecution, but it lingered for a while. Their philosophy was built around rationality of nature. Pythagoras declared that all of nature is rational. Now, we normally think of rational as being well-ordered and orderly and sensible, but literally rational was a ratio of integers, fractions. So in other words, they assigned numbers to things. The sun was a number, the moon was a number, earth was something else. They would assign numbers of things and make these clever arguments to explain nature through these fractions. And so that's how they whiled away their time. Well, it's a crackpot philosophy by modern standards. We would call that numerology. But they did contribute something of lasting value. Was the musical scale. The notes we use in music were, the tuning of them was first really defined by the Pythagoreans. And they used their simple fractions. You take a string and divide it into certain simple fractions like 1/2, 2/3, 3/4. Those shorter strings would produce higher notes. And by using those fractions, you could define the notes of the scale. And that method of tuning actually persisted for a long time. It wasn't until around the Middle Ages that people began to tinker with it. And finally around 1720, the well-tempered method of tuning was created, and about everybody tunes with that these days. But anyway, that was a lasting contribution of the Pythagoreans. So, but the Pythagorean theorem was actually known about 1,000 years before Pythagoras. So there's evidence the ancient Babylonians knew about it, and even ancient Chinese. So it had been around a long time. And I'm not sure why Pythagoras got credit for it, or gets his name on it, but it is associated with rationality and irrationality of numbers. In fact, their whole underpinning of their philosophy suffered a huge blow when someone discovered that there was something in nature that was not rational, and it was a square. Suppose you have a square with sides of length 1. The diagonal of that square could be found by using Pythagorean theorem, and it's simply the square root of 2. Well, someone managed to show that the square root of 2 is a number that cannot be represented as a fraction. So I may talk about this in a future video and show you why that's true. I think that's a fascinating issue in itself. But the square root of 2 cannot be written as a fraction. Therefore, it was not rational. We call that irrational. It's an irrational number, in fact. So that actually, the legend has it that the fellow who discovered that was towed out to sea by the Pythagoreans and drowned because they wanted to keep that a secret. Otherwise, their party would end. So anyway, they played rough with math in those days.